Good afternoon. Thank you for tuning into my poster. My name is Amanda McGowan. I'm currently a postdoc in the Addiction, Health, and Adolescence Lab at the University of Pennsylvania, and I'll be sharing our recent work on controllability of structural brain networks and negative affect variability in daily life. So first, I would just like to take a note and a moment to thank our funding support and collaborators. This is truly a team effort, and I'm grateful for all of their support. So affect is dynamic and it fluctuates in daily life. And by intensively sampling a person's affect across many occasions, we can ask them how negative they feel in the moment. And they can rate from, not at all to extremely negative. And by doing so, we capture a pattern that shows peaks and valleys as people go about their daily lives, experiencing the highs and lows with meeting the demands of daily life. And these fluctuations differ between people. So take, for instance, person A with a usual negative mood of about 32, and then person B who has a similar usual level of negative mood around 33. And so although both these people have similar usual levels of negative mood, or what we might call average negative mood in daily life, how much they fluctuate around these usual levels differs. And so we see that here we have person A that has these fluctuations that are more closely around that usual or average level. And we have person B that has peaks and valleys that are much further from that usual level. And so we consider this to be called affect variability, and it's usually represented by the standard deviation of that time series. And while it's normative to have some variability, too much may be indicative of difficulties with emotion regulation. And so at the extreme, we see individuals with depression report greater negative affect variability than those without depression. And greater variability in negative affect also predicts future affect disorder onset and episode recurrence. However, understanding brain structure correlates of negative affect variability, or just affective variability in general in naturalistic settings, has been limited. So using network control theory, we examine facets of brain structure that may enable this greater negative affect variability in daily life. So 95 young adults underwent diffusion-weighted imaging, and then the data underwent tractography to map white matter fiber streamline connections between 214 cortical and subcortical regions. And then the resulting structural brain networks consist of nodes representing regions connected by edges, which are the links between the nodes representing the number of streamlines connecting them, normalized for density. And structural brain networks were analyzed in a network control framework to compute the structural support that 17 functional brain networks offer for moving the brain to easy to reach state following control input by calculating each network's average controllability. And so participants provided 2 reports per day of their negative affect on their smartphones as they went about their daily lives. And they responded to the prompt, how negative do you feel right now, on a scale from not at all to extremely. And here we can see data from 2 participants, person A and person B, both representing real participants in the data set, and they have similar mean levels of negative affect, around 26, represented by that black dashed line. However, person B, as you can see, shows greater negative affective variability, shown by that gray highlighted area, which represents their intra-individual standard deviation of the negative affect time series. And multi-level models indicated that the strongest association indicated by Cohen's D between negative affect variability and average controllability was observed in the cingulate-insular region, highlighted in yellow here on the left. And it's also known as the salience or ventral attention A in the YEO atlas. And the association between average controllability and negative affective variability was only significant in the cingulate-insular system, and this was following false discovery rate control. And participants with higher average controllability values on that x-axis, we used the average of the rank-based inverse normal transformed within each network, within each individual, exhibited higher negative affect variability along that y-axis in their daily lives. And so this association between average controllability and negative affect variability remains significant when we control for false discovery rate, as well as other covariates, including total brain volume, in-scanner motion, average levels of negative affect. And these findings are also unchanged when we remove a potential outlier that's not depicted in the figure. And so overall, we find that greater negative affect variability related to the presence of more depressive symptoms, consistent with prior work, but we don't find that the average controllability of the cingulo-insular system was associated with depressive symptoms. So average controllability was unrelated to depression. And overall, our takeaway is that average controllability of the cingulo-insular system seems to promote this normative levels of negative affect variability in daily life, rather than that associated with depression. And thanks so much for tuning in, and I look forward to chatting with you about any potential questions, and feel free to reach out.